Hello everyone, welcome back to this live stream about software development, front end. This is the second session. We started a week ago with the basic scaffolding of our project. Today we should be able to complete the topic for our isomorphic. The idea is we are going to prove the application, including some type of state management, transferring that state from the server to the browser, also using that state in the browser rendering in the hydration process. And we will also try to improve how our URL, the URL of the application is getting processed. As you can see, we stopped the project exactly in the same place where we finished last week. I pushed this code to GitHub, so now you should be able to see in the description the link for GitHub. If you wanted to pull that code and run in your own computer, that should be easy. Also, I only changed one line of code before sending to GitHub, and you may remember from last week we were having like some error messages when the browser was trying to load the favorite icon, and the favorite icon was not available. So the idea now is that I included a single line of code here that is basically a way to tell the browser, like, don't worry about that favorite icon. And from now on, we should have less of those error messages. When I was watching the live stream again after, I saw that there was a moment where I ran the application and a log appeared in the console twice. And the second time was because the browser was trying to load the favorite icon, and that was generating the same log again. Let's see. Okay, we can start now trying to understand a little bit more of that transfer state. And I think now is where I call, like, we started the content for today. Let me set up my camera a little bit bigger, and we can go over that explanation. So last week we covered like how the application would work. Like, we had the entire flow where we run some code in the server, and then that server will run that code internally and will generate some kind of HTML page, and that HTML page is sent to the client. The client will render that page to the user, and as that page finishes displaying to the user, the client tries to internally execute the same code that was executed in the server and tries to reset that appearance to the user. So basically, the client is trying to generate a visualization that is identical to the visualization that the server created. Let's give us an example. So imagine we have a page. Our page has a menu, A, B, C, and some content. This could be generated by the server, and the server will send this data to the browser. But when the browser runs again, they will try to create exactly the same rendering, pixel by pixel, exactly in the same positions. And then the browser will try to replace the one that came from the server and inject a new version. We covered that last week on why that is important, because the client may be able to inject extra bindings to the page to make the page more responsive and make that interactive. So that's why we end up creating a representation that is identical to the server side, but with those extra bindings. The main problem is, if the server had some kind of data available to the server to generate this page, that data will need to be available to the browser to create exactly the same representation. One example, imagine we have an API call where this list that we generate here is coming from a database, for example. We have names of users that come from a database, and if the list of names is not visible to the browser will not have that list, and the list will be empty and have no data to display. So that's what we are talking about. So if the server has any data that was used to generate this page, that data will also need to be available to the client, so the client can use that and generate the page identical to the way that was built from the front. That's the part of this part is what we are calling the state, And making this object available to the client is what we are calling as transfer state. So we need to make that state available to the client so that the original rendering of the page in the client side is really identical. And when we swap that content to the browser render, there is no flickering, like the user will not really realize. Like the page is there, exactly the same, suddenly it becomes interactive. That's what we are trying to accomplish by having this data available to the user. It is possible that instead of having the transfer state, you would rely on the client doing an API call to retrieve exactly the same content. Imagine a scenario as the server calls an API or an external API, and you can make the client also call that external API and retrieve the same content. So both would rely on the external API to build that data internally. That would work fine. But the problem is the time to the page to become interactive would be longer, because the user would need to see the server-side rendered version of the page longer until that API finished loading, and then the hydration process would be able to complete and make the page interactive. So if we can eliminate this type of API dependency, our page can be interactive earlier, and then the time where the server-side rendered will be visible to the user could be shorter. That tends to deliver a better user experience to people if you can eliminate as many dependencies you can, like this API. That's why instead of relying on the client doing that API call again, it's more common to embed that JSON as part of the page itself, and then as the browser executes, then the data is already there, and we can generate that visualization exactly the same as the server side. I hope that was kind of a good high level. I definitely see that will make more sense as we go into the code. But yeah, let's start going and making this happen. That's going to be very interesting. Let me go to my corner again. So to achieve this state in the transfer state part, there is a progression that we will need to evolve. And I believe that the first thing we will need to improve in our application is how we handle query parameters. So what I mean by that. So imagine we have our application here. We can go, for example, if you see in the URL, we have like that page 1, and we could send messages like a test equal 1 2 3 blah blah blah. So you see that key value pair that we have we can send it to the server, and if we are able to process that query parameter and make that data available to our component execution, that would already be the very first representation of some kind of state. Like it is possible to almost reduce the need of a real state in the application by having the query parameters being the representation of the state. For certain scenarios where we are consuming from external APIs or reading from a database, that's not applicable. But for simple applications, and that's what we are going to start here, that is actually possible. So what I wanted to try first is somehow having a counter where I have a page with a plus button, minus button, and as I click on them, I can increase or decrease a counter. And this is something that doesn't necessarily need a single state in the application. The URL would be a good representation of that. We have here in the entry point the moment where we are parsing the URL. So here is the moment where we receive this entire URL from the browser, including potentially some parameters. So imagine we have this like test 1 2 3. So this entire URL is what we receive here as part of this request.url. And we are using the native Node.js parser to give us only the path. But Node.js has an option where if I provide a second parameter true here, you can see here TypeScript is telling me parse query string true. And now I am able to also use the query object. So the query object will tell me all those parameters and everything that is available to run. So I could now, with that query object, I could make that query available to my browser, to my component, sorry. And with that available to my component, then depending on what is there, the component may render one thing or another thing on that. So here, what we will need to do, as I'm providing a new parameter, I will need to make that parameter visible here. And that is type any, because I don't really know what is going to appear there. And what we can do here, I'll try to display that element. I'll try to display it in the page so we will be able to see if it's working or not. So I'll receive the query. Query can be anything, any key value object, and let's display as part of the page. As I changed the signature of this method here, I will also need to provide that query string to the component in the browser. So let's see here how that goes. So you will see this root component is already complaint that we don't have a query to use. What I'm going to do is I'm going to write like a very, very small function that is like a naive query string parser here, only for the context of this example. Here I'll have like a query ts that is going to be a simple query string, query parser. So I will receive some kind of query string. Normally you should be able to do a lot of processing, like parameter names can be repeated in the query string, and then they should be treated as an array of values. There are some considerations to do. I'm going to do the simplest way possible, where I'm considering that parameters are only going to appear once, and I only have that as a key value. That will be simpler to deal with. But I know this is not the normal scenario. Like a normal query string parser should be able to deal with way more concerns than what I'm writing here. Then I can get my query string, and I can try to first split that by this symbol. This is going to break that into an array of name equals value. So now we can map this array. And this array should be able to be broken now by the equal symbol. So I will have some kind of param, and I can return the parent.split into a equals symbol. Okay. So basically what we start with something like this: test equal ABC, and test2 equal 1, 2, 3. This is how everything looks like in the beginning. After I do this split, I will have something like an array where I have the test equal ABC here. And I will deal with this question mark in the beginning later, so probably don't worry about that. And then the other value we'll have in this array will be the test2 equal 1, 2, 3. So basically that's what I'm doing here. This first line breaks that into that array. The third line will break that into an array of arrays, where the first value will be test, for example, and then the second value will be ABC, and then the second array will have test2, and then string 1, 2, 3. So this is what this line is doing now. Now, as we have an array of arrays, we can start reducing that or processing that to transform in a key value pair. So I will write here a quick reduce that will be able to get all those entries of arrays and break that into a single object. Let's see here. We can receive some accumulator and some item, and I will return the accumulator. Okay, that's a good way to start. Now we have that accumulator. I can inject as part of this object I can inject a new key value that will be, the key will be the item position 0, and the value will be item position 1. I will actually remove this question mark from the parameters earlier, so then we don't need to worry about that, and then that should be able to give us a clean object to deal with. But yeah, this is the query parser that I am going to use. I will export this. Here we can get those objects, we can import our query parser, and now with the query parser created, we will be able to call the query parser with the query string that we have from the browser. And the way we get that is from the location. We have a search object. So the search object is the representation of that the parameters, that string with the question mark key equals value. And we are going to send the search to our query string, but you remember that question mark in the beginning. So I'll do a quick slice 1 here only to remove that. And with this, I should be able to have our query object ready to be sent to our root component. Yeah, see, now the URL that I provided now was broken and generate an object with exactly that execution. And here we can see if I provide another like name equals testing name, we also have that as part of the execution. So now I can provide as many key value elements to the execution, and that should work fine. And we can try to calculate, yeah, our links here, they are not providing any parameters, but we can calculate it to see if the front-end execution is also working fine. The way I can test that is by changing our menu, and we can, for example, include here in the page 1, I will say value equal 0. That's an let's see how that works. So as I click in the menu, that will be processed only in the front end, but that value equals 0 should also be seen in the page itself. Let's see how that goes. Render, yeah, and now I will refresh this page. Now let's have a look here. So if I have the link, I click on that link, you see that the link provided the value equals 0, and that was processed in the front end side. So this means our query string parser worked. Is still a very naive implementation, doesn't worry about all the concerns that a query string parser should worry, but is something we wrote ourselves, so you should be able to understand exactly how that works. Real project, use a library for that, is simpler. We are going to transform this page 1 is something like a counter where I can add or remove numbers from that counter. Let me see. To start that, I needed to remove first that query string parser here. I don't want that to be displayed anymore. I'm going to make our components to also receive the path and the query, and they can do whatever they want with that. To achieve that, we need to provide here in the types saying that they receive a path that is a string and they receive a query any. And then becomes kind of optional if they don't use that. That's not a big deal. What we can do now is to go to our component and start using that. So here I will get the path string and the query any. As I'm sending the value equals 0, I will be able to retrieve that value from the query if I destructure my query, and I should be able to now display that value, something like a value equal and value. So whatever value I provided to that execution, that's what I'm going to see here. Probably we need to deal with the scenarios where the value is not provided, the value is not a number, the value, like there are multiple scenarios to deal with, but let's test this configuration first. And let's see if we are able to display that value in the page 1 correctly. So refreshing here. And yeah, you see value 1. If I navigate to other pages, nothing really displays yet, but value 1 is there. And I can now actually provide whatever value I want. And you see that that displays that. You probably can see where I'm going, what I'm going to do here. Like if we display as part of this component, we display buttons to add or remove numbers. That should be an interesting way to deal with this counter. And I can get inspired by the links that we already created here in our menu to do that. So I'm going to copy a link from here, and I will include some links in this page where I can link to the same path where we are now, because I don't want it to deal with that recalculation. So if I link to the same path, but now where value equal 1 or equal value plus 1, I can say need to transform that in a number. By the way, all the values inside of the query string are strings, so you need to transform it in a number first. So what we could do is const number equal value. If I have a value, I want a number of that value. If I don't have a value, assumes 0. That should be a good again, this is a very naive. I know that I'm going to call this always with a number, so this number here is not going to be a big deal. And instead of using the value now, I'm going to use this number variable, and we can do here number plus 1. This is going to be our URL, the plus button. That's where the plus is going to link. So I can call here or add a plus symbol, and I can have a minus symbol where I say that number minus 1, and we link in that as a minus, and I change the symbol. So now what I'm doing here is I'm creating HTML links that are able to link to the same page, to the page itself. That's why I point to the same path. But I'm providing the values always with an increment with whatever value I receive, or a decrement of the value I received. And now I'm going to, as I click in those links, I will do a navigation in the page, and I will recalculate that entire page, re-render everything with the new number that I have. That's how I will be able to keep clicking in the plus button and the number should go up, keep clicking in the minus button and the number should go down. And this is a very earlier definition of a state, where we are using the URL and the query parameters as the state of the application. Let's refresh this page. Now we have the value equals 1, and we have here a plus and minus, and they look very close to each other. I'll need to deal with that, but I'll try to click here in the plus, and we go to 2, 3, 4, 5, 6. You see the URL there? So when I click on this button, I am actually sending that information to the URL, and I'm actually re-rendering the page with the new number. And that's why I can have this plus and minus working fine. So I don't really have a state coming from the backend yet, because the URL is the state of the application. And if I do force a refresh of the page, you see that I'm calling that page with the correct parameter, value 7. And you will see that I am receiving those two links, where the plus link will link to the same page providing value 8, and the minus link is calling the same page, providing value 6. So that's why the plus and minus are working, because we have the dynamic generation of those links going to the different numbers. And that should work with basically any number that you provide. You should be able to call that page and go plus and minus anytime. Let me split those buttons, make them like more presentable. So refresh that page. Yeah, now I have the plus and minus, and I can click on this and click on this. Yeah, good. I think our query parameter part is working fine. We have the page 1 as a demonstration of the query parameter, how that is working. Let's jump into the real thing, the state now, how we can deal with a real state of things. And if you saw my browser here, you saw I had another tab open here with the Star Wars API. So my intention is to be able to consume from this API, get that data, and create a page that is able to display that. Let's go back to the board to explain how that is going to work, as then you will have the context of how things will be. So I wanted to have some kind of page where we have that menu we already have today, the one that is navigating between pages. One of those pages will load this Star Wars display page. So as soon as you access this page, we will have the names of some people there. And to load that people page, we will use this API that is in the screen right now, the /people. As you can see, that generates a result with some people in the list. This API has pagination, but I'm happy with the first page only. So we are going to display the first page here. And then as we click in one of them, then we are going to load their information here. And you will be able to navigate between them as part of that navigation. So this is going to be interesting, because the server will need to consume this API and will need to make that data available to the client to generate the first rendering. But as we navigate between page to page, the client will also need to load that API to get the extra data that was not originally loaded by the server. That's why this is going to be a very interesting configuration, because we will have a transfer state only for the most necessary data to render the current page, but all the navigation API calls will still need to be done from the front end. And in the front end part, that is going to be a very interesting way when we need to deal with the asynchronous calculation. For context, imagine you are loading, you render a page, and that data doesn't exist yet. So you navigate from one button to another button. You render the application. As you render that, the application triggers an API call, and that API call will take a while to return. So you will render some kind of a loading animation to the user. And when the API returns, then you replace that loading animation to the data that you actually wanted to display. This kind of a process of display an animation and waiting the app to the API call to finish, and as that finishes, you re-render the app, is something we will need to deal. That is probably one of the things that will bring more complexity to our small framework here. But I know a way to make it work. It will look ugly, but it will be good to understand how those processes work. So let's start with that. And we can go into let's look into this API first to understand how that works. So as you can see, we have a possibility of calling this URL, like the Star Wars API /people, to get everyone, and then you will get the entire list of people. And you are also able to call that with the position of the ID. So for example, if you get here the first person in the list and you call people/1, then when you do that request, you get only that person, only, in this case, Luke Skywalker. And my computer is not working. Yes, see, people/1, then you get only that person. So that's how we are going to do. We are going to do the slash people to build the menu, but as you navigate, we call only the people slash the position in the list to get them. And to create that, there are a lot of things we will need to create to support that. The main topic I see immediately is the capability of reading external data. So normally, if you are building only front-end applications, you probably can call like a fetch for an API, and then you get the data. The problem we have here is we are in the isomorphic, so we needed to deal with the data retrieval in the back end, and we needed to deal with the data retrieval in the front end. In each one of those environments, they work differently. So if we can provide some kind of helper function to our common components, so they can call this helper function with the data that they need, and the translation layers would translate to those environments, that would be the ideal scenario. And what I'm thinking is to have some kind of a helper function like called fetch that we call, we executed the components with the fetch object, and they are able to deal with that on their own. So then we don't need to really, as part of the component, they only needed to trigger that fetch function that we wrote, and that will translate to the environment how to do that. It will make more sense as we go. Let's create that a simple implementation of a fetch function here. I'll create a new file here. I'll call fetch yes, and this file I will export. Export a function called fetch, and this function is the one that will be the responsible to translate all the API calls that my application wants to do to be executed in the server-side way. So the server-side way means we will need to open an HTTP request or to call some API. Normally, if we are going into a real application, you would probably install Axios as an interesting library. One of the interesting points of using Axios as a library is Axios is a red isomorphic. So that should run very well in the front end and back end. But we are going to make things here in a simpler. So the way our fetch is going to work, we are going to receive some kind of URL that is a string, and we are going to call to execute that URL to do something. Our URL may be HTTP or maybe HTTPS. Okay. Normally, you wouldn't need to deal with that definition, but the API that we are going to use right now is definitely HTTPS only. So to deal with that, I'm going to import the HTTPS helper. So import HTTPS from HTTPS. So that's going to be simpler. If you use the HTTPS with HTTP URL or vice versa, sometimes things don't go very well. And now I can do a HTTPS dot request, and that's how, like a very low level request, that's how it would work. This API, the idea is that this is going to, we would need to wait for a promise or something. So as we executed this request, we wanted to encapsulate that in a promise. So when that is done, we can resolve that promise, and whoever is waiting for that can receive the data that they are waiting for. We could actually start by returning new promise, and that promise can resolve or reject. Very basic promise definition. Then inside of the promise, we are going to start that request. The request is normally going to be only GET request. We don't need to deal with a post to read the Star Wars API, so it should be fine. We are going to read that URL, and that URL will receive the URL, some parameters, and a callback function. This callback function has the response object that we will need later to process the execution. And as we finish the building of this, we need to do a .end. So this .end will tell the HTTPS helper from Node that we finish configuring our request and is ready to be sent. As part of the response execution, we needed to build up all the chunks. Like normally the HTTP implementations, they are able to get fragments of data. As you download those fragments, you can receive them and start processing them earlier. And you needed to build up all those fragments in the end as the final message. Again, we are going very low level in the HTTP implementation to avoid having the libraries or things like that. But this should be easily replaceable by a library, or even node fetch would be the same API as the browser fetch. Const, I'll have here the chunks that will be string array data. So this event on data is executed every time we receive a fragment in the response. So as we are downloading, this download, as I said, it could be very, very big, and we get small fragments. So for every fragment that we receive, we wanted to include them in the chunks array. So later we are able to chunk.to string. We are already stringifying that here. And then basically we have another event that is the on end. That means all the chunks are transferred. So it means everything is already available in the chunks object. And now we should be able to resolve our promise with the final result. So here is where I can resolve with JSON parse. I know that the Star Wars API only returns JSON. If you are dealing with other types of APIs, you don't want to immediately parse that. So resolve JSON parse of chunks.join, and I'm joining with no character in between. So I'm getting a string of an array of strings and joining everything together as a single string and sending that as the resolve of my application. And only as a to simplify, if we get any problems, if I do on error, what I'm going to do, I'm going to reject that with the same message I receive from the on error. So this should be easy. Like if we end up having a problem, like the network has any issue, that will reject the promise and we will see the error message in the console. And yeah, that should be it for, again, a very naive implementation of a fetch API for Node.js. For the browser side, we actually, this part will be simpler in the browser because the fetch already exists in the browser itself. But we will need probably to still wrap that fetch function to have our fetch function, because the native fetch implementation wouldn't require us to do extra things. Like we get the URL, but we needed to fetch, then we have another promise to wait to convert it to JSON and do the JSON parse and everything. So we are going to have a similar function like this in the front end part, and let's do that now here. So I'll create a file called fetch. Yes, and I will export a function fetch. So the idea is to have exactly the same process. We have the same URL string. So as more similar the interfaces of those two functions are, easier will be. But now we think we are in the browser context. So the way to deal with that in the browser would be slightly different, and we would need to call the fetch object of the browser itself. I already called it fetch here. So if I call fetch, the execution will get confused. So I'll go window.fetch. That's the object that I'm going to call with the URL, and we can start dealing with those objects. So I could also make this async, and I can await that fetch to happen. Const result, and then as I have that result, I would do result.json. That is another await, and that will give me the JSON of that result, and I could actually return that, and done. That's the same concept of a fetch, but for the browser part. It's only an encapsulation in a simple consumable promise. Would be simple enough to use. And we would be able now to provide this fetch function to our execution. So here in the index, I can execute the root component with the path name, query, and fetch. We will need definitely to load that fetch function here, because as I don't have anything imported as fetch, the code thinks I'm talking about the native window fetch, but let's import it here. Import fetch. Fetch. Yeah, now we are talking about our implementation of the fetch function. And yeah, definitely. We will need to include that fetch function here. That is going to be a function that receives a URL string and returns a promise of any, because that's the API we have. Later we can make a like more descriptive what we have, but then we have the fetch function here, and we will need to include the fetch function in the server side execution as well. Fetch, and in this part I will yes. Okay, so now I'm giving my front end, my common execution, the common objects. I give them the possibility of triggering HTTP requests. So now anytime I want a component to deal with that HTTP request part, I can call them with fetch. And the way I'm going to send the fetch object down to the dependencies. And I will also say that this fetch component here is going to be part of the objects that I receive here. Yeah. It's getting a bit bigger here. I can extract the data type, the component in a single interface. I think that would be good to do that. Let me see. I will have some kind of I component, and this should be export interface I component. So my I component object is basically function. Yeah, that would be a type in this case, but is a function that receives those parameters. Yeah, this guy. So I'm actually going to change that to a type. So the component, I'll say equal this. So now we have that component type, and that would be simpler to us to only say here. And then the same, this root object would be a component object. So that would be simpler. Then as we update that single interface, that would affect most of it. Okay, now what we have here, we are receiving the fetch object, and we are sending the fetch object down to our dependencies, to our subcomponents. And something we can do now is in our page 2, for example, we can receive that path string, we can receive the query, any, and we can receive our fetch function. That fetch, I can export const page 2. It's a component equal this, yeah, and we can import that component, yes. So the interesting on doing this is because then I don't need to specify the types of things anymore, because the component type already knows everything, and that would make the code simpler to deal with. So yeah, as you can see, now I only received the path, and TypeScript already knows that's a string, a query, and a fetch object. Now we have some interesting thing, like we are able to load that API there, like the Star Wars API. I'll copy this, and I call that Star Wars API / people, and then, and now we have some type of data with the people here. Let's see, data, and what I'm going to do, I'll do a console log of that data, but I'm not really doing anything yet. I think you can already realize, like, we are getting to a problem of that asynchronous situation, because when this component renders, we will trigger this execution, but especially in the server side will already return a page where the data is not there. So we will need to have a way to this server to wait all those asynchronous executions to finish. We will need to populate all that data somewhere and then render the page in the end, not in the beginning. So it's almost like we need a double render. But let's run this content like this to see how things are going to not work. If we see yarn start, at least we should see some API calls, and we should see the data coming back from the server. But oh, okay, we missed something. Let me see. Still isomorphic. Ah, no, it was in the server part, so the server part didn't find it. We can load this function here. As part of our file here. I'll load that in the end, so we don't to worry about that, and no need to import this fetch anymore. We go back to application, we go to the page 2. Yeah, you can see here in the console we have a people call. So we did call the Star Wars API from the front end. See, Star Wars API dev / people. We received the data from that result in the front end, and we also had a call to that in the back end. So you see, this JSON in the console is the result of that API call. So we also had a call for that API in this backend. So backend and front end both triggered API calls. But by the time that the data was available, the page was already rendered and visible to the user. So that's the part, the asynchronous part that is complicated. Like, you can trigger API calls, but you need to have a way to wait those API calls to finish and then re-render the page as you complete that. And that's the part where a state is very valuable. So a component needs to have some state, so you can change that over time. Like, you would be waiting the API to finish, or the API may finish already, or we're presenting a submenu, the submenu is open or closed. Like, you needed to have some kind of variables that help the component to know how they should be presented to the users. And some of those variables will be changed based on asynchronous requests. So that's the main problem we have now. We have an asynchronous request, but we don't have a state to organize and wait that asynchronous request to be visible, to re-render the application. So to continue into this process, we will need to have some ways of storing this data. So as those APIs, they are triggered, we trigger the API for the Star Wars API, we get this data. We needed to get this result and we need to store somewhere. So I can safely trigger a new re-render, and this new rendering will be able to get that data and then display an interface to the users. So this place will be the global scope. In our framework here, we are not going to have a scope per object. Normally, React or other applications, they have like Angular has like the component classes to represent components, and they can have their own state internally. We are not going to have a state per object. We are only going to have the global state for the entire application. And for this type of project, that should be simple enough. If I need a state per object, I can always create a subfield inside of the global state to represent the data, and that should be good enough. So now we need to start with that concept of the state. Okay, so we need a state object to treat that. And the way I'm going to do that is by creating a simple const state empty. So this is our state object, okay? And as part of our state object, I will need to call my root function with that state object. So I can say here, hey, here is the state for you. That state may already contain some data, may not contain some data, don't really care, only render that content. And I think to simplify, this is kind of getting a bit clunky, this execution. So I will extract this execution to happen here in the beginning, so I can have the result of that execution, and then I only render the result here. So that's going to do some separation of what we are doing and what we are rendering, because I could even extract this in another function later. But the main point is, as we get to that rendering part, it means don't worry, we finish the execution, and during this process here we may need to wait some things to confirm if the state is populated or not. So extracting that execution here will be good. Now, as I'm providing that state to the component, now we needed to make the component aware of that by including the state object. And I think I'm going to convert this object in a component as well, because we are getting, then we can take advantage of the interface I created before. So I have a const root, this is a component, and is equal this guy, and has this. So the good point, now we can simplify a lot of the TypeScript definition here, and I will be able to go directly to the component type that we created before and tell that we now have a new parameter that is going to be the state object. So we have here a component that receives this, receives the fetch, returns a string, and also receives a state that can be anything. Yeah, that's it. So with this, our root component should now know about the state, and we are now forced to send that state to the child element. So I will receive here state, and we need to pipe that state to the child element. So our component now has the visibility of that object, that state object, that is provided by the root component. Now, we will need to deal with the same concept from the front end. So the front end, we will also need a state object that we are going to provide as an execution here to our components. And you probably see what I was talking about as the transferring of the state. We eventually, all the data injected in the state by the backend will need to be visible here to us to use. But as a start point, let's create a similar code where I have an empty state, and I call this component with my empty state here, only to solve the type definition. Okay, going back to the server here. Providing that state on its own is not helpful. I'm going to the component, and I'm going to start using that state. So now we get to a very interesting point where I receive a state object, and this state object may already contain the data I need to display the list of people, or may not contain that list yet. And I think that's the point where we are going to start changing the execution of our component. So we can say state dot people. If I have people in that state, I will return, and let's do a simple page 2, and I will only stringify that list of people for now, only to be simple, only to prove that the data is visible to the user. So JSON dot stringify state dot people. So this is a scenario where that the fetch call that existed down there already finished, already had the data available, and already injected that data in the state. And that's exactly what we need to do if we don't have that data yet. Then that's the case where we are going to trigger our fetch function. And then what we do as the fetch finish, we go to the state dot people, and we inject the data that we need. The data that we need, if we look to the response API, so we have the data, and let me go slash oh, you can see here that that's inside of a results object. So I'm going to already create only the array of results, so I can do like data.results, and so far we should be good to go. You can see that now our fetch, we trigger the fetch, that fetch mutates the state, and then we do something with that. If the state already had the data, then we only display. Okay, we are still far away from having this working. This is not going to work yet, but this is a very important step to have the information we need. Let's try to rebuild and rerun that application, and we can see in the browser how things behave. I know that nothing is going to display in the page yet, but now at least we have this concept of a state going all the way through the object. And as I refresh the page, you will see I still have a call to the API. So that means this call to the API is there because the state object was empty. The state that we had in the front end was empty. And that's true because in the front end here, as you can see, I'm always, for every rendering time, I am creating a new state object. So that's why it's always empty. If you see here in the server side, we have this original execution. We have this call here for the result. And the main point is, at this point, after we do that root execution, you can see that our state was empty in the beginning. Okay? We always start with an empty state. We do the root execution. And at this moment, we have the page always rendered as a loading page. Like here. I forgot to write it, loading. So we will always have that page in a loading state when we have in this moment from the server side. So what we need to do here is somehow identify that the fetch function was called, and we needed to await that to finish. So we have the state populated with all the fields that were necessary, and then we re-render the page again. So in the server side, we will need that double rendering process to be able to fully build the page in the server side with the data there already. And yeah, that's going to take longer. We will render a page to trigger to have all the triggers, and then we render the page again with the final result. the problem we see, there are scenarios where based on the result of one API call, we needed to do another API call, and there is a chain of execution. Most of the frameworks, they have ways to identify those dependencies and weight them here. In our framework, we will have only one layer, like you needed to call everything you need from the first execution, populate the state, and have one chance of weighting that. I can have some kind of a list, const promises. That will be an array of promises, and I'll say here is a promise array, the promise of any array. Okay, so I have that list of promises that somehow my component execution can populate that list of promises from the fetches or from any other async definitions. And then what we are going to do is I will wait that list of promises to complete. So the list of promises that I have will need to finish somehow to process. So I will have a promise.all promises. Okay, so I will wait all of them to finish. And as they finish, then I can re-render the page with the correct state as the result state. And then the way I'm going to do that is I will trigger a new render inside of this function. That is actually the real rendering. See here that I can actually move this. The first render I'm actually not interested, so I don't really need to save the result. This is the first render is to trigger all the API calls that needs to happen. Then I wait all of them to finish, and then I have the real execution where I'm interested in the result. And then this is the page where we are going to really deal with the rendering part. So what I can do is actually move this entire rendering part inside of this promise and do the result.end there. And the interesting thing is, for some reason, if I have a execution that doesn't have any promise, the promise.all that we are calling here is able to deal with that. Like a promise of all for an empty array is going to immediately execute that second part, and that shouldn't be waiting anything. So now what we need to do is be sure that when we call the fetch function, we actually populate the promises array correctly, and then we can wait that data to be presented. And probably something we could do is to actually provide some kind of a wrapper into the fetch function. I'll call here const fetch wrapper. That will be a simple function. This function will receive exactly the same parameters from the fetch, so it will be a string, and it will return exactly the same fetch object. So this is only a wrapper, a dummy wrapper around the fetch function, but the fetch function returns a promise, right? So then what I can do is get a fetch promise. That is the fetch promise I will return. So I will return the fetch promise, but I can also populate my list of promises with this fetch promise. So what I'm doing here is I'm trying to intercept all the calls to the fetch function in a way that later I can wait all of them in a single placement, and then only when they finish, then I'm going to actually call the rendering of the function. And then now, instead of calling my root execution with the original fetch, I can call with this fetch wrapper that knows how to deal with this object. Probably not ideal, a bit ugly code, but that should be enough to make this server-side rendering process to work. And we can see, like, let's see how that works if we are able to access the server-side rendered now with the fetch. Yeah, now we are suffering from the problem that I described before. Because of that data, the state, the global state object is not sent to the front end. The front end is not able to generate a equal representation of the page the same way as the server side. So the main point we needed to do now is actually make that information available to the page, so everything should be simple. And the main thing that we needed to do, like let's first filter the data that we have, because we don't need this entire results page. So we can map each item into a new object. So it will be a new object where I only needed the name of the person. So item, and I think his name, yes, item.name. And I only needed the index, but the index is already the index in the array. So then I only needed an array of names. Yeah, only an array of names then. So yeah, and our type definition requires parentheses. Interesting. Yeah, so basically we'll get the list of names only and displaying the page. Okay, now we have that state file. The state file means when we run the second rendering in the backend, the state file already had that object populated correctly. Now we needed to make that object visible to our browser execution. And this is the transfer state part. Normally, even if in React, when you have a Redux, this is very common. You would create a script tag where you are going to generate a variable, in my case, state. And I'm using var here because that goes to the browser. I wanted that to run into a wider variety of browsers, even the ones without const or things like that. And here, the state is going to be the JSON.stringify of the state object. So the idea is to get the state object and print that as part of the HTML. Let's have a look on how that is going to work. I have the page here. The page now was created with the entire list of names as we wanted. And if we go to the response, we now have here the printing of the state object. As you can see here, we have the script where I have a flag called people and the entire name of people that I had. See? So basically, the state object that was used by the server to generate that page is now visible to the front end. And now we only needed to make the front end use that state. So the way that I have is, instead of using this state object, why not go to the state that is visible in the window object? And I can say window.state. And only to make TypeScript happy, I can declare var state any. So then that should be happy. Oh no, it's not happy. Global. And I will say window as any. So that's the kind of things like in TypeScript. If you in a real project, you would create the interface that extends the window to represent the objects that you have there manually, things like that. Here I'm going only to ignore that to simplify. And that is interesting because now I should be able to get that same rendering from the server identical in the browser, because now we have access to the same execution. Yeah, see, now the server side render looks identical to the browser side because the browser has access to the state that was created by the server. Cool, I think we got to an interesting point now. I think this transfer state part was probably one of the areas that is more complicated to understand. And yeah, that's a simple way to us to deal with the transferring of the state and everything. Let's transform this list of names in a menu that we can navigate, and we will be able to actually display the correct data. Probably something we can do is create some links where we have here page 2 where person equal and the index of that person, like person 1, person 2, person 3 as the index of the array. That's probably simple enough. And the index of the array, only to be sure, when we call /people/1 means I'm talking about the position 0 of the array. So I need to get the array and some 1 to display, but we will get to that point. Let's make this as a interesting menu first so we can navigate correctly between those pages. To do that, I'm going to this page and in this part. So this is the part where we have, considering that the state already exists, now I need to generate that menu to navigate, and I'm going to get strongly inspired in our menu object. So I'm actually going to copy this menu, and we can actually create something similar here. So I don't need that there. I'm going to create this, and then when I map that, I will need to join that with an empty string. Only then we don't display the array there. But then I'll get each person, and then for each person, I will generate a link in this menu. Let's do. I'm going to do something like this. Yep. That's kind of an interesting encapsulation of backticks inside of backticks, but this is for if you have any React experience, you are familiar with this. I'll say a person, that is any, or this is a string, yeah, person name. So we have I'll call actually as a name, and then with this name we are going to say let's link to /page2 where person equal and then the index of that person. So we need to map the and the same, or actually index +1. That's also going to be the URL for the HTML execution in case we don't have JavaScript. And here we are going to display the name of the person. Yeah, that should be good enough. 6 is number, and this looks a bit hard to read. Let's reformat this code so at least we have something readable. Yes, this should generate some kind of menu that we can navigate, and let's see how that works. Yep, that's there, so I can click Luke Skywalker. The URL there is changing correctly, so everything is working okay. So I have the same page, and that's working fine. I think it will be simpler if we don't map this object. Imagine we have the entire object here. As I have that element, now I can search inside of that array for that position -1. I'll call item, or this is any, then here have the item.name. Now we are talking about the entire object. Person index equal. If I have a person, I want a number of that -1. If I don't have a person, then I have an okay. Then what I'm going to do, if I have a person index, then I will render that. So let's make something here only to make that more readable. Then you will see that that entire state object, the entire result of the Star Wars API was visible in our result here. So we can see here now, yeah, you see the entire object of the Star Wars API is here now. And that's how the front end was able to also render the page exactly the same way. Now let me see, we got a person 1, so we should be able to go to that list index different than now. Let's see, now I should be able to go to the person 1. Yep, and now I should be able to navigate between people here. Yeah, you see how I can navigate between them. In this case, we are not doing an extra API call because the state file that was sent to the front end already have the data of everyone. So now this navigation is happening as a browser only navigation and only displaying the data that already exists in the browser. Idea. Okay, so if I have the person parameter or person index is different than now, means I need a person to be loaded. And I'm kind of assuming that if the people object is not there, then the person object is also not there. It's impossible to be there. So then I'm always going to trigger both. So, and then I have here person index, and then I have that data, and then I can inject that in the state object somewhere else in a different area of the object. So I'll say state dot people data, that, and I'll call that as an array. So I needed to initialize that array to be sure that like it may be already there, may not be there. So I'm kind of saying if it's not there, initialize that array, and then what I'm going to do is injecting that data, but in the correct index. Wait, that's not going to work in an array. Let's create as an object. That's going to be easier because then as a key value I can do thing and I can do person indexes. Okay. So as I retrieve the data, I can retrieve the entire list or the list and the person. Let's start testing this concept and see if that brings us somewhere. Okay, loaded too early, or the server totally died. Yes, the server totally died. Why? We are calling slash. Did we call? Tried to call some API, but it didn't work. I think I know what happens because when we go, for example, /1, I think we needed to call /1, and there is need to have a slash in the end. So that yeah, maybe we needed to also the final slash. This is ugly. Let's, it was the slash in the end. So let's have a look on what we have as part of our object. Oh, we have here people data as an empty object. Yeah, in this case I don't want that to remove one, so I can actually use the person, of course, because there is no result. Now I wanted the data itself. Results was something, yeah, see the copy and paste problem. Sorry, now everything should be fine because I'm trying to read a field called results from a JSON that doesn't have a field called results. So yeah, okay, that's the problem of doing things live. And now our data object, yeah, see, now we have the data object with the right elements. Now we do have the data to display the user. So we can start now going back to our rendering here. And instead of reading this from the people array, we can go from the people data array. Okay, so this is where we can get that from. And that should be good. So let's see how that is going to work. Here things should work fine. Yep, things is still rendered correctly. I still got the same C3PO when I call API 2. I know when I navigate to other links here, things are not going to work. So because data is not going to be triggered. Yeah, see, undefined, because my state object doesn't have that data, and I'm not telling my state object how to deal with that data. So what we need to do here is actually start a process where we don't have the data available. I will need to render a loading or something, and then render that correctly. So how we can do that is by checking the and I say if that data exists, okay, good, render it. Let me see. Yes, can do the same check. So what I can do actually, the const page data equal loading. That's the default data. The default is I'm loading the page. Then if the data exists, instead of displaying the loading, I'll say page data equal phi of the page data. So this should be data. Okay, now we can actually display only the page data, and we don't need to worry about this calculation or anything like that. So here it goes. We are getting to the point where we will be able to render the page from the server side with the minimum state file as possible to that data to exist there. And then as we navigate from page to page in the front end will trigger to retrieve the extra data that it needs. So this is trying to get the application to a more realistic point instead of relying only in the state file that was transferred from the server. The front end should also have access to APIs to retrieve data. So that's what we are trying to do here. As I navigated to a page, I should re-render from the server side. Yeah, see, all the data is there. And as I navigate, now instead of receiving undefined, I should receive a loading. Yes. So now that's the moment where we would trigger a loading for that data. We wait a while. So this loading could be an animation or something. And then as that information comes received back, then we re-render the app to trigger everything. So the point we have here is a very interesting, because if we have the data, okay, display. If we don't have the data, now is also a moment where we would need to do a similar data retrieval, similar to what we did here in the full page load. I'll kind of have the same code there. Normally we would have that in a service, we'd trigger that only once, but so far this is okay enough to us to go here. Page data, let's change that. We will start the page data as empty. Then I will start checking this person now in separate. I need to break the check of the nullability of the person index and the existence of the data, because the nullability of the person index means the parameter to who to display is not available yet. So that's why I wanted to confirm. If this is different than null, means I have someone to display. If this is not true, means I have no one to display and I don't need to do anything because I don't have anyone to display. Okay, now we have the second check, where if I have that person, then I would trigger, I would display. If I don't have the person data, then I trigger the call. See, now I don't have that warning here anymore telling me that the person index is not available. And then what I can do here is, as soon as I check that information not there, then I get the page data to be equal loading. Okay, so if I call the page without any parameters, then I'm not going to load anything, so no need to display that load. And this code is start getting more and more complicated. So let's see how we can simplify that later. But if you follow the entire video step by step, you should be able to follow, because I'm trying to explain what is in my mind as I write the code. And if you are watching offline and you have any questions, write in the comments. I'll be happy to answer that. And if I have the questions before I created the shorter video, I can actually answer them as part of the shorter video as well. Okay, so we should have a interesting process where after this code executes, now we need to trigger some kind of re-render of the page. Let's test this to see how that works. And we may need to have a new function that will flow all the way to the components to be able to trigger the re-render of the app. But let's see here. We'll do a full page reload from the backend. The scenario that we are talking about is where I don't have any parameters. So if I don't have any parameters, only the menu should be rendered. And we can see here that in this case, our page is very simplistic, like we have only that object. We can now start filtering those objects again because we are not using them to display the content. But we have a very small state file. Now, as I click in the element here, now I should try to call the API, render everything, and trigger that. So let's have it from the server side. That's where the code is visible to us here. So then the server side knows how to deal with that. But I deal with the navigation, and that's not. So the interesting thing I saw here was that when I navigate from this page, I click here, but nothing happens. Why nothing happens? Person here, do we have, see, we are having a HTML error. Okay, that's why. So that is coming from page 2, line 55. So some HTML error is happening because we are calling this and cannot read property 3 of undefined. Okay, so undefined, that means that people data is undefined, and that totally makes sense because that object never exists. Okay, yes, so we needed to check if that object exists and contains the object. Done. Now things should work. Yeah, that was interesting because we were clicking and that was not re-rendering. Definitely it was something going on there. Let's test again. Now the page, see, the person index is null. As I click, I should see the correct person index and a loading animation. And in the network, we should see the call to the person. Okay, now we are in the point where I wanted to be, where we can now start with the concept of triggering a re-render based on the final execution, the finish of the execution of an asynchronous call. So basically, the entire flow, we have the component rendering first, and that component doesn't have the data that it needs. So as part of the rendering trigger, we trigger this fetch function. And then the rendering finishes and display the loading animation. Now the fetch finish will take a while to execute and will finish and will populate the state file with the correct data. But only populating the state file with the data is not enough. We also need to trigger a re-render for that, so the data that exists now in the state file could be used in a new rendering process. And the way I want to do that is somehow to call like a render here. And we have the render object in the global scope, right? We could call from there, because remember, we are in isomorphic. The render object doesn't exist in the global scope, the server side. The server side doesn't have a render in the global scope. So that's why we will need to provide that as a call to the function itself. So let's go back. Let's say our component now needs to receive also a render function that will be a function that returns void. So it's a very simple function. Provide. Now with that, a lot of things break. So I wanted to receive the render function. Provide that function. Yeah, and now we needed to provide that render function from both environments. Let's have a look here. Let's start with the backend. What could be our render function in the server side? And I think server side, like the concept of a re-rendering is actually not really necessary. We could provide like a dummy function, a function that actually doesn't do anything, because in the server side, calling the re-render is not necessary. Like the main point is server side will wait out those promises to finish anyway, so that's why there is no need to have a re-render there. And we are going to provide like a nope function, doesn't do anything, because for us in the server side that's relevant, but it's good to have that function so the interface of our components are identical. Then in the front end, we are going to provide the render function, and the render function can actually be the same render function that we already have. So if I do render, that should be enough. And now we are giving the ability to our components to trigger a full re-render of the page. So let's use that ability in the end of the execution of our process. One of the interesting things, we are only doing this manual trigger of a re-render because this is a very simple framework. Most of the frameworks, they know how to trigger a re-render as you mutate the state. One example is React. As you set any object in the state, React knows to trigger the re-render to apply the changes from that state in the page. But we don't have that, or we don't have anything listening to our state to trigger that magically. So that's why we needed to trigger that re-render ourselves. And the way we do that is by getting that function that we made available all the way from the top execution, and I call render. Cool. That should be an interesting point where we should have a application working now, consuming from API from the backend and from the front end part. Let's have a look now. Let's do a full page reload here from our home page. So let's do a full overview of the entire application now, because I believe that should be working fine. The page 1 was where we created the data plus and minus, like it's a counter, and that is actually only using the query string as a state to manage what to display. Page 2 is where we created the concept of the page, and the original page was not loaded. Yes, we missed one trigger in the re-render part. Here. As we do this, we need to render as well. That's why that call didn't work. Okay. Cool. Let's see now. Early? Yes. Okay. So if I go here to home and refreshing the home page. Why is it important to refresh the home page? Because then our state file completely empty. So there is no need for a state file to render the home page. So all the data will be triggered by the front end now in this example. Then we go page 2. We show the loading. The loading was displayed as a result of the rendering of this loading page here. But that triggered this execution here. And then as the people array was visible, we re-render the page and then we display the menu. And now I can click in a person here. I can load and display. See, now I have a full front-end application that is able to load the data here from the front end. And as I force the refresh of this page should come from the back end complete with all the data that we had, including people data and the list of arrays. So let's filter this array again to have only the names. Now that we only need the names, no need to transfer so much data. And now our application actually gets very specific on the state that we're transferring, like only the minimal state possible transferred to the browser. Let's filter that again. So here we have this result, and I will map that dot name. We don't need that. This item, yeah, I don't care. And now that we have item.name, this is an array of strings. So when we get to this here, we are going to say this item, the string, fine. And here we go. That should be enough to simplify the amount of the size of the state we need to transfer. And now we have a full working application. Even if we turn off JavaScript, we have this application fully working. I will disable JavaScript. Let's see, go to the home page. Like I can go to this plus and minus. You can see that this plus and minus is working because I have the full page reload. See? And I can also go to the page 2, where that is going to load this menu or load the menu with the content. See? And that now, without the JavaScript, everything still works because I'm doing the full page reload and my server side knows how to handle those two things. Now, if I add JavaScript again, now I can do the same navigation and you can see, oh yeah, reloaded the page. Now I can go see. Now I only loaded the JSON that is that fragment of data. I don't need to load everything. And as I slowly populate the state of my browser, if I go back to the page I loaded before, I don't need to load that API again. See, the state object is already there, so I don't need to load that data again. And yeah, that's how we get the minimal size for our state as possible. See, the list of people now is basically only a list of the names, and I have only the person that I am displaying coming from the server side, and over time I can actually include even more people there. Let's have a look in our state. Now that I navigate into multiple objects, let's see what the state looks like in the browser side. So over time, I got a part of this object came from the server in the very original execution. And then as I navigate in the pages in the front end, I had more API calls to increment even more the data there. So now I have way more people data there, but the list of names are still the same, you see? So only one of these entries in this object actually came from the backend. Everything else was populated in the browser. I think we got to a very interesting working state here, where we have a fully working API browser that is fully isomorphic, and probably we can complete our isomorphic concepts here. This project wouldn't be too hard to also start having some forms, submitting some data, having some extra things like that. Wouldn't be too hard. I'll push the changes we just made here to GitHub as well. Thank you again for your support. Yeah.